Well, hello lads, so we're going to have a quick look at the sine rule. Now, the sine rule, it's in your log tables, and I would really encourage you that if you think you need to use it, write down the sine rule. So, let me explain how it works. If you have a triangle that's not a right angle triangle, that means a triangle you can't use Pythagoras on, or sine, cos and tan, which we used from the previous videos on. This is where the sine rule comes in. And it's a very simple rule. Okay, let's say I have an angle A, and let's say the side opposite has a length of small a. And let's say I have a side that has a length of B, and I have an angle opposite called B, and a side or an angle called C, and a side opposite called C. Well, the sine rule says that if I take the length of one side and I divide it by the sine of the angle right opposite it, the answer should be, as a fraction, equal to, if I take any other side and do the same thing. Okay? Now, this allows you to create two fractions with an equals between them, which means you can solve it very easily. Now, there's two ways of solving these, and I'm going to show you these two ways with two examples. Okay? One where the side is missing, and one where the angle is missing. So, here's the first one. This is where a side is missing. Let's say x is a side and it's missing. But we do know the angle opposite it. And we do know another pair. Let's say that's 9, and let's say that's 33. These aren't to scale or anything. So let's first of all look and see, do we have enough? It's not a right angle triangle. I could find that missing side by adding the angle by missing those two up and dividing or taking away from 180, but we're not going there. So I have enough. I have one pair and a second pair, one pair and a second pair. So let's set it up the way it says: side divided by the sine of the angle opposite is equal to side divided by the sine of the angle opposite it. Now, when you get to this point, if it's the side that's missing, all you have to do is say that the side is equal to this multiplied by this. Every time. So long as the side is the bit that's missing, you just multiply the other fraction by the angle. So let's see what this answer is. They usually tell you to the nearest whole number, nearest decimal place, nearest degree, or whatever. So fraction 9 over the sine of 33. And make sure you close the bracket on that 33. Then come out of the fraction, multiply by sine 68, close bracket. And you get 15.32. Now, let's have a look at what happens when the angle is missing. Let's say this is 71 degrees. And let's say this is 22 centimeters or meters or whatever, it doesn't make a difference. And let's say this is A. And let's say this is 15. And I want to find the angle A. Well, I set it up exactly the same way as this. Okay, so watch. Side over the sine of the angle opposite. Side over the sine of the angle opposite it. So, this is different. This time we have the side. It's not like this one, and we're missing the angle. So how do we get the answer? Well, this is what you do. The angle is going to be equal to, and this is a lot more tricky to remember, so just practice it. The sine inverse, and then you're going to put all this in a big bracket. Turn this fraction upside down and multiply by that. So I'll show you how I do that in the calculator. So, sine inverse, big fraction, sine of 71, close bracket, over 22, come out of the fraction, multiply by 15, and make sure you close the bracket. and you get 40 degrees. Okay? So that's the basics of how you do it. Now you can replay this a few times to get this algorithm correctly. Okay, I'll say it one more time. If the side is missing, you set up your fractions and you just multiply the fraction that you know everything about by the angle that you know, and that'll give you the missing side. If it's the angle that's missing, you flip the fraction you know upside down, you multiply it by the number, but you get the sine inverse of the whole thing. Okay, so I'm going to do two more just to show you. And then you can practice away to your heart's content on as many of these as you want. Just follow the same methodology. Now remember, why are we using this? Because we can't use Pythagoras. And you need pairs. You need a pair. Okay? So, this one, an angle is missing. And this one, we're going to put we'll put side missing. Okay? Right. So, let's do this one first. Side missing. So, I'm going to set up side over sine of the angle opposite is equal to side over sine of the angle opposite. And you'll notice when you do these, you'll always have one fraction that you know. So because the side is missing, we don't change anything. Side is equal to fraction multiplied by the angle. So let's work that out. 26 over the sine of 58, close the bracket, come out of the fraction, multiply by the sine of 22, close the bracket. And you get 11.48. Now, this time the angle is missing, so we set up the fraction as normal. Side over the sine of angle, side over the sine of the angle, side over the sine of the angle. Now, because the angle is missing, what we're going to do is the sine inverse, big bracket, turn this upside down and multiply it by that. So let's do that. That's going to be sine inverse, big fraction, sine of 66, close bracket, over 18, come out of fraction, multiply by 11, close bracket. And that's 33.9. Let's call it 34 degrees. Okay, so there you have it.